Well, hello, East Rockaway. Here we are with a little earth science and our reference table, page 5, plate tectonics, or tectonic plates. I'm first going to start off by pointing out the key, which labels the different plate boundaries. They show the arrow showing relative motion. So the first plate boundary is your transform plate boundary, and notice the arrows are moving side to side. San Andreas Fault, great example. We'll see that in a minute. Moving on to our divergent plate boundary. Notice arrows are moving apart. To diverge means to pull apart. Finally, we have our convergent plate boundary. To converge means to come together. Notice the arrows are moving towards one another. They also point out subduction zone. To subduct, like a submarine, means to go under. And sure enough, we'll see subducting plates, as they write here, are the more dense plates, generally oceanic crust. Oceanic lithosphere is more dense and will subduct. Compared to with these little bumps, these little boxes, those are the overriding plates. Generally, you're forming mountains on the overriding plate, volcanoes. They show a symbol here with the dashed line, which are the complex or uncertain plate boundaries, and mantle hotspots. We'll mention a little bit about mantle hotspots. Okay, so let's take a look. Let's go and start with the transform plate boundary. I'm going to go right here to, here's North America, right? That's us right there, right? Notice we're sitting right in the middle of a plate boundary. But I go all the way over to the west coast, like California here, I hit the San Andreas Fault. Notice the arrows moving in opposite directions. So that's a great example of a transform plate boundary. Okay, moving along. Now, I love the example of the mid-ocean ridge and the mid-Atlantic ridge splitting apart North America, South America, Africa, and Europe, Asia. All right? There's a divergent plate boundary here. We have all this new seafloor forming. Literally, new lava is forming right at this zone here, pushing it away like a conveyor belt in both directions, moving the continents further away. Our youngest seafloor is forming right in here. We pointed this out yesterday during the lesson. The seafloor gets a little bit older as you move apart. Okay, the last plate boundary, and I think we used this as an example yesterday, is the Nazca plate with the South American plate. If you notice, the two arrows are coming together. They call it the Peru-Chile Trench. We'll talk about what a trench is. A trench is really a good indicator of what's happening below the surface. It helps to support that one plate is subducting. In this case, the Nazca plate is subducting because on the South American plate, I have these little they're not triangles. They're little squares, rectangles. That's the overriding plate. And sure enough, I get the Andes Mountains all along here. Okay, and the last thing I'll just point out real quickly are these hot spots. Hot spots, Hawaiian hotspot, Yellowstone hotspot, Iceland hotspot. Right, they're all over the place on this map here. All right, look at this over here, Tasman hotspot. Okay, so we'll pause there.